Hi guys, welcome back. This is Professor Hank, and in this video we are going to talk about two-dimensional lists in Python. Okay, specifically we're going to cover four ideas. First idea being that a two-dimensional list is kind of like a list of lists, right? You can think of it as a list that has as one of its members, or as its members, a list or lists. Okay, so to support this, the syntax we're going to have to add is basically we're going to add an additional index, right? So when manipulating two-dimensional lists, you're going to have two indices or indexes, however you want to say that, instead of just the one that you normally have with a one-dimensional list. Right, commonly, two-dimensional lists are used to model tables. Think rows and columns. Think Excel spreadsheets. Okay, and so when processing all of the members of a two-dimensional list, of your list of lists, you're going to have nested loops, right? So you got one loop for going through every element of a list, but when each one of those elements themselves is a list, then you need another loop to process the lists that make up the elements of the list. Okay, so it sounds a lot more complicated than it is. You know, we'll have a sample program as usual, to walk you through it so you'll be able to see it in practice. All right, so let's take a look at some code. First off, how do we declare two-dimensional lists? Okay, so what you do is you nest list declarations. So let's say that I was going to create a two-dimensional list called L. And if this was just a one-dimensional list, you know, like say with integers, well, you're used to that, right? I mean, that's no big deal. So that would be a three-element one-dimensional list. But since this is a two-dimensional list, the members of the list aren't going to just be, you know, say one value, one integer, one string, one float, whatever. They themselves are going to be lists, right? So I'll go ahead and just stick with integers just to keep it on the simple side here. So 867 and 530 911, right? So instead of having a list that was just three integers, now I have a list that contains three lists, each of which contain three integers. Right? So this is a two-dimensional array. Okay, so that's one way that you could write it, where the first element of list L is this list right here, and the second element of list L is this list right here, and the third element of list L is this list right here, right? So that's one way that you can write it. Another way that you could write it is by splitting this up to where each list is on a separate line, right? You don't have to do that, but you can. Okay, and by doing that, it makes it a little bit easier to see, you know, what we're talking about here. And, you know, this first list is going to be element 0 of the list L, right? And the second list is element 1, and the third list is element 2, right? So let me go ahead and print this two-dimensional list for you, just so you can see what it looks like. Let's see here, gmail.py, right? So you can see that the print statement shows a list. You can see those outer square brackets of lists, right? So it's a three-element list of lists, where each element in turn is its own three-element list. So L, since it's got three elements, right? And each list itself is three elements long. This is often referred to as a 3 by 3 two-dimensional list. Okay, so looks really easy to see how this might be considered a table when I write it like this, right? So if you write it like this and you think about it as being a table, then this first element here becomes the first row. The second element of list L becomes the second row, and then the third element of list L becomes the third row. Okay. Okay, so we can process L as a one-dimensional list in similar ways to what we've done before, what we've seen before with one-dimensional lists. So for example, I could write a for loop where I say for list, right, in L, right? And then I'll go ahead and print list. Okay, so what's going to happen with this? Well, this is going to behave similar to what we've seen before with one-dimensional lists. That is that each element of list L is going to in turn be copied into list, right, to that target variable, and then we'll print that out. So when we run this, let's see what we get. Okay, let's see here. I think I missed an extra T here. So let's see what we get. Try again. Okay, so you see these three lines right here? Now, this is the result of us printing each element of L one at a time in turn, right? So this caused us to print this list, 867, on the first repetition of the for loop. Then we printed the list 530 on the second repetition. And then we printed the third list, right, on the third repetition of the for loop. Now, what about using subscripts, right? So you can use, with L, you can still use a single subscript or index. Subscript, index, those terms are interchangeable when dealing with lists or arrays. Depending on what language you're dealing with, they'll use one or the other. But regardless, right, with list L here, we can still use a single index because it is a list, right? Just so happens to be that it's a list of lists. So for example, I could do something like this, print L of 1, okay? Now when I do that, we're gonna end up printing out the second list in our list of lists. So there's the 5, 3, 0, right? That's the second element of list L. And so I used index 1 to access it, right? So you can still use your single index in ways you've always used it for one-dimensional lists. It's just that index 1 is referring to the second element or the second member of list L, and that second member just happens to be itself a list. Okay, no problem, no big deal. Okay, so what about, the second index that I've been talking about, okay? Well, let's bring in that idea of a table to help us explain that, right? So I've already written at the top middle of the screen here, that statement that created our two-dimensional list, okay? So we'll have that for reference. Now, if we consider this to be modeling a table, right, you can think of it as something that looks like this, right? Let's have an abstraction, okay, where we've got the 8, the 6, and the 7 in the first row, right? So we've got our rows and we've got our columns, okay? So we got 8, 6, 7 in the first row. We got 5, 3, and 0 in the second row. And we've got 9, 1, 1 in the third row, okay? Now, this is two-dimensional two-dimensional list L, right? Two-dimensional list L. And each one of these rows corresponds to one of the elements in list L, okay? So this first list is L of 0. The second list is L of 1. The third is L of 2, right? Remember when I did print L of 0, we saw 867 on the screen, right? So that 867, that is element 0, row 0, right? 530, element 1, row 1, element 2, row 2, okay? Now, here's where that second subscript is going to come in, right? So we can think of the 859, the 631, the 701 as all being different columns, right? So the first column is going to have an index of 0, the second will have an index of 1, and then the third will have an index of 2, right? So now if I want to access any one of these individual cells within this table, within this two-dimensional array, if I want to access any one of these individual elements, then I'm just going to add a second index. So let's say that I wanted to change the 0, right, in that second list from, let's say I want to change that to, I don't know, 14. Then what I would do is I'd have the name of my list, which was L, and then I have that first index, but that first index is going to be 1, right? Maybe L was a bad choice here for the name of the list, but I'll just make it an uppercase L for this example, just so it's easier, so we don't accidentally confuse it with a 1. But anyway, so I want that second row, I want that second list, I want that second element. So I'm going to have index 1, and then I want the third column, or the third element in that list inside my list of lists L, right? So I'm going to go ahead and I'm going to specify 2, right? So that's going to get me to the second row, third column, or it's going to get me to, another way you can think of it is, it's going to get me to the third element in the list, which is the second element of list L, right? And so if I want to change that, I think I said 14, right? Then I would just have an assignment statement that looks like this. So that 0 would then get overwritten with 14. What if I wanted to print out the 9? Well, then what I do is I'd have my print statement, and then I'd specify the name of the two-dimensional list. I'd provide the first index, which gets me to this third list, right? That's row 2, that's list 2. And then I'd say, well, I want the first item in that row, in that first column in that row, that first element in that list, right? So that would mean I would have index 0. And so that will put 9 on the screen. Okay, so let's see that play out in code then, right? I wanted to change that 0 to 14, right? I think that's what we had. So L of 1, right? So that's going to get me the second element in list L, right? Which is the second row. And then I need to get the third element of that second list, right? That third column, which is going to be index 2, and then I'll assign it 14, right? And so I'll go ahead and print that out now. I'll print that position out, L of 1, 2, just to show you that, yeah, it's changed, okay? So before I changed it, right, it's going to be the printout L of 1, 2, right? Then we'll change it, and then we'll print it out to show you the updated change, right? So there's the 0 that was in that position. That's the result of line 17. And then I changed that 0 to 14. And so then we see the 14 as a result of line 21. Okay? So really that's it. You're just saying, okay, in list L, let's go for that, let's specify, which row we're interested in, right? Which element in our list of lists, which member inside of L, inside of our two-dimensional array, and then we have to turn around and specify which column, right? So which element in the list that is itself inside of a list, right? So the 8 is at position 0, 0. The 6 is at position 0, 1. The 7 is at position 0, 2. The 5 is at 1, 0. 3 is at 1, 1. The 0 is at 1, 2. The 9 is at 2, 0. this one right here is at 2, 1, and this guy right here is at 2, 2, right? So I made a nice little square matrix, a nice little square two-dimensional list, but you can make it any dimensions that you wanted. You can make it configured any way you want. You can make it 3 by 5, 2 by 8, 12 by 6, whatever you need. Okay. Here's another little interesting factoid. You can mix lists and other types of data, right? So I could do something like this. I could say, oh, well, the first element of M will be 8, and then the second element will be itself a list, and then the third element will be, a string, right? So if I do that, then I have what's, you could consider it to be what's called a ragged list, right? Where, this first guy right here is essentially a list of one element. This guy right here is essentially a list of one element. And so it's not nice and even, right? The first element's only one thing long, the second one's 2 things long, and then the third one is one thing long. But anyway, that's kind of, going off of a rabbit trail there, going on to a rabbit trail. So let's go ahead and print out the contents of this list. So for E and M, right? And then we'll go ahead and print the E, and we'll see what we get. Okay. So you can see there's the 8. That was the first item. That was assigned to the E. And then there's our list 1, 2. Right? That was the second item that was assigned to E, and then we printed it. And then you see the low. That was the third item that was assigned to E, and then we printed it. Okay, so let me give you one more example here. One more thing to talk about, and that is an example of processing a two-dimensional list, right? So let's say that I wanted to find the total of all the integers in my 3 by 3 two-dimensional list here, right? I'm going to need my accumulator variable, okay? And I'm going to have to go through, and for each list, I'm going to have to total up the contents of the list, right? So this is going to call for me having nested loops. So let's say that I wanted to just add up the total of one list, right? I'd have one loop to do that. So I could do something like for n in call it L, or call it list, right? Some list, okay? And then I would do something as simple as plus equals n, right? Because if list was a one-dimensional list, each item of that one-dimensional list would be assigned to n, which we then in turn would add to total. Okay, fine, right? But that would only work for one list that I call list, right? If it's a two-dimensional list, as I have here, right, I have to process every single element of L. Okay, so I'm going to need a loop that's going to take me through that entire list. Okay, now it just so happens that each one of those elements is in turn itself a list, right? So what will happen is that this outer loop will go through list L and will assign to E the first list. Okay, so once that happens, then I'll take the body of that outer loop and I'll use E, right, as part of the inner for loop, right? 8, 6, 7 will be assigned to E, and so then I'll just, go and do the same thing, kind of, right? Where E will be 8, 6, 7, and so then my inner loop will then traverse through, or will then process the 8, 6, 7 list. So that 8 will be copied into N, and then the 6 will be copied into N, and then the 7 will be copied into N, right? And so when that inner loop's done, 8, 6, and 7 will all be added to total. So total will have in it, at that point, 21. And so then that will be the end of the first repetition of the outer loop. Then the outer loop will start its next repetition, which will be to copy 530 to E. And then the inner loop will do its thing again. It'll just traverse or process that list 530, which was assigned to E, doing the adding thing again. And then the same thing will happen for the last element in the list, right? So let's go ahead and print total after that is finished, okay? So we'll go ahead and run it, and so we'll see 40. So does that make sense? Well, 8 plus 6 plus 7 is 21, plus 8 is 29, plus 1 is 30, plus 1 and 9 is 40, okay? So let me show you another way of doing it. We'll use while loops, okay? So with while loop, what I'll have is I'll have R will stand for rows, okay? And I'll initialize that to 0, okay? And so while R is less than what? Less than the length of L. Now what's the length of L here? Well, the length of L is 3 because it's got 3 items in it, okay? So for each repetition, I'm going to do something, but at the end of that repetition, I have to change R to 1, okay? Now, inside of the outer loop then, what I have to do is I have to go through and have another loop that's going to be responsible for processing each one of these individual lists, right? So I'll create another variable called C for columns. That'll get initialized to 0. And so while C is less than what? Well, less than 3, okay? Because each one of these lists is 3 elements long. There's nothing really for me to use len with here because there's only the one list, right, which is the two-dimensional list itself, so I can use that in my outer loop. But for my inner loop, I can't use it at all. So if that's confusing, then I can just change that to 3, right? Because how many rows are there? There's 3 rows, right? How many columns are there? There's 3 columns. So maybe that's a little bit easier. Okay, but anyway, so as the inner loop goes, it's going to have to increment C also, right, to eventually cause that inner loop to terminate. And then inside of here, I'll add to total what? L of RC. L of RC, right? So when this is finished, I'll put some white space here just to kind of break this up. When that's finished, total is going to have 40 in it, right? Now, it's going to have 40 in it only if I reset total back to 0 here, otherwise it'll have the 40 from the previous for loop, right? So I'll reset total back to 0, and then what's going to happen here is that R is going to start off at 0, and so 0 is less than 3, that's true, so then we'll set C to 0 here, and so C will be less than 3 because it's 0, and then total plus equals L of RC. Well, what's R and C at that point? 0 and 0. So we'll add to total L of 0, 0. Well, what's L of 0, 0? 8. And then C will change to 1. Go back to the top of the inner loop. Is 1 less than 3? Yes. So we go inside the inner loop. And what do? Add to total R of C. Well, R is still 0. It didn't change. But now C is 1. So we're adding to total L of 0, 1, which is 6. So total will now have 14 in it. So next up, C will change from 1 to 2. Go to the top of the while loop. Is 2 less than 3? Yes. So we add to total L of RC. R is still 0. That hasn't changed yet. So we're adding to total L of 0, 2. Right? So that is going to be right here, 7. That is L of 0, 2. Row 0, column 2. So that'll add 7 to total. Total will now be 21. Okay, and then C will change to 3 because we add 1 to it. Go back to the top of the while loop. Is 3 less than 3? No. So then this while loop is finished, and then we continue on to line 26. Now I is going to change, or excuse me, R is going to change, and so R will become 1. So then we go to the top of the outer loop to see if we have another repetition. Is 1 less than 3? True. So we enter the body of the loop. Line 20 sets C back to 0. So then the inner loop starts up, is 0 less than 3? Yep. So line 23 happens. So we add to total L of R, C. Well, what's R at that point? 1, right? And what's C? 0. We just reset it. So now we're adding to total L of R, C, L of 1, 0. What's 1, 0? Well, this is row 1, column 0. So we're adding the 5 to total. Okay, and it's just going to lather, rinse, repeat. It's going to continue doing that. Okay, until the outer loop finishes its repetitions. So let's go ahead and print total, and you're going to see, the 240s. So they work in different ways, right? But you get the same results. Now, let me go ahead and put print statement inside of here, where I'll go ahead and I'll print. Let's see. I want to print out the RC inside of here, just so you can see how R and C is changing. Okay, so we'll go ahead and run it, and you can see, it was R and C. R was 0, C was 0. R stayed the same, then C became 1. R stayed the same, then C became 2. Right? But as soon as the inner loop finished, right, 0, 1, 2, C became 0, then it was 1, then it was 2. That finished, and then the outer loop finished its repetition. The R changed to 1, right? And then the inner loop did its thing, 0, 1, 2 again. So you can see how R is changing and how C is changing through those repetitions, right? So RC, 0, 0, then 0, 1, then 0, 2. And so it's going to be L0, 0, then L0, 1, and then L0, 2, right? And then when R changes to 1, the inner loop does all of its repetitions. And then when R changes to 2, the inner loop does all of its repetitions. So how many total repetitions did we have? Well, we had 3 repetitions for the outer loop, right? It says, take a look, R only changed to 3 times, okay? And then we had 3 repetitions for the inner loop for each repetition of the outer loop. So when R was set to 0, we can see that C changed from 0 to 1 to 2, right? When R was 1, C changed from 0 to 1 to 2. When R was 2, C changed from 0 to 1 to 2. So how many total repetitions did I have? 9, right? So for every repetition of the outer loop, you end up having all of the repetitions for the inner loop. So there's 3 repetitions for the inner loop times 3 repetitions for the outer loop, 9 total repetitions. Okay, so how about another example here? So what if I wanted to show you the total row by row, right? Or list by list, right? So I wanted to show you the total of this list, which is 21. Then I then wanted to show you the total of this, which was 8. And then I wanted to show you the total of this, which was 11, right? So here's what I have to do, okay? I'll go back to using the nested for loops because I think that's a little cleaner, less code to write. So the outer loop, again, is going to be iterating over list L. So that list is going to get copied to the target variable, then that list, then that list. So we're going to go row by row, right? So for each row in list L, right, what are we going to do? Okay, well, I'm going to need a total variable that's going to add up all of the numbers in that row, all of the columns in that row. Okay, so we'll set that to 0, and then I'll have my inner loop here, and I'll say, all right, well, for each column in the row, what will we do? Well, let's add to total that column. Okay, and so when we've finished adding up all the columns in the row, when that's done, I'll go ahead and tell you what your total was, right? So your total for this row, right? So I'll just say row is, and then I'll show you the total, okay? And so that right there will give you a row by row, right? A row by row total, right, of all the values in that row. So your total for row 867 is 21. Your total for 530 is 8. Your total for 911 is 11, right? So this right here, the body of the outer loop here, I was resetting my total for each row. Then I was adding up every column in that row by adding it to the total, and then showing you what your total was for that row. Okay, and I had to repeat that for every single row. Now, let's just see what would have happened if I would have put the print statement at the very end, right? Okay, the only thing that I'm going to see then is your total for 911 is 11, right? Because that was going to be the very last row that we saw. We only repeated this one time, right? It wasn't part of that outer for loop, so it didn't get repeated for every single row. This was just a result of the last row. Okay, so this really should have gone right about there. Okay, now let me see here. I want to show you one more thing. I keep saying that, but really this is going to be it. Okay, how about I show you the average for all the numbers in the two-dimensional list. Okay, so how am I going to do that? All right, well, I'm going to figure out that total again. But again, this is going to be like what we saw before. I want to find the total of the entire list, right? So I'm only going to set total to 0 one time. So we'll go ahead and we'll say, all right, well, for each row in my list L, my two-dimensional list L, we'll have that. And then we'll say, well, then for each column in the row, we'll add that column to our overall grand total. Okay, so once I've done that, total is going to have the total of all the rows and all the columns in those rows, right? So there's your 40 again, right? But to find the average, I got to divide that total by the total size of this list, right? Now, it's not going to do, you might think, well, hey, we'll just print total, or we'll find out the average by taking the total divided by the length of the list. Now, it's not going to work, okay? Because, right, 40 divided by what is 13 1/3? 40 divided by 3, right? This goes back to that idea of what I was talking about before, a list of lists, right? How big is L? L has 3 elements. It just so happens to be that each one of those elements is itself a list. So how many members are there to L? 3. And those elements just lists themselves. So what I have to do is I have to say, oh, okay, well, I have to add up all the lengths of all of the lists in L. So what I could do there is something like this. I could say, let's find the total number of elements in L. So we'll say total elements, right? So we'll initially set that up to 0, and then I'll have a for loop, okay, where I say for rows in, for row in L, right? So we'll go row by row, and we'll add to total elements the length of that row, okay? So now I'll print total elements at the end. Let's see what we get. Okay, so total elements equals length of row. Oh, it would be useful if I actually did a plus equals, wouldn't it? So let's try that again. So there you go. There's your 9, right? So for every row, I found the length of that row, and that's 3, that's 3, that's 3. And so I added 3 to total elements 3 times because there were 3 rows in L. So there's your total of 9, right? So now what I'll do is I'll show you the average right, by computing the average as total divided by the total elements. Okay. And then we'll run it. And so then we'll see the average for this is 4.444444, right? So it takes a little bit of thinking, takes a little bit of understanding about how the two-dimensional lists work, how loops work, the for loops, the logic, you know, where you put stuff. See, I put total equals 0 inside of the outer loop when I wanted to total up everything row by row. But when I wanted to get the total of everything, well, then I put it before the outer loop, right? So that way it didn't get reset for every single row. So thinking about two-dimensional lists in terms of a table, in terms of rows and columns, might make that a little bit easier. But really what's happening is that you have a list, a single list, right? Which I call L. It's just that it's a list of lists. That's what makes it a two-dimensional list, right? So L, its length is actually 3 because it's got 3 elements. It's just that each one of those elements in turn themselves are a list. And to access them individually, you know, you can access the elements themselves for L as you would any one-dimensional list, just using the single subscript. But if you then in turn want to access one of the elements in the list, which itself is an element of list L, you got to add that second index. Okay. Okay, so let's summarize what we talked about. We talked about two-dimensional lists, 4 things, right? So it's a list of lists, right? So you've got a list that has as its elements lists, right? And so showed you a bunch of different ways to manipulate that list of lists, but if you want to specify one of the individual values within this structure, right? 2 indices or 2 indexes, right? So the first index tells you which element you want to access in the list of lists, or as an alternative way of thinking about it, which row, okay, if we're thinking about it in terms of a table. And then the second index is corresponding to the element in the list, which itself is an element within the list of lists, right? Or if it's easier to think about, the column, right? So 2 indexes, one for the row, one for the column. 2 indexes, one for. Let me just show you another way. I know I was summarizing, but let me just show you another way of thinking about it, right? Another way you can visualize it. Okay. So we had that list L, right? 8, 6, 7, 5, 3, 0. Another way of thinking about it. Okay. Doing my best here. Okay. So here is the index for the first element of L. Here is the index for the second element of L. Here is the index for the third element of L. Now, in turn, each one of those elements are lists, and so they have their own indexes, right? So if I want to access the 7, I got to specify the first element of L, and then I have to specify the third element of that list at L of 0. Okay? So maybe I want to print it. So that might be another way you can think of it. So I've given you 3 ways of thinking about it, and I snuck one in during the summary portion. Okay, anyway, so use the model tables. Okay, use two-dimensional lists very often, tables. And then I showed you how to process a two-dimensional list in multiple ways using nested loops. Okay, nested loops. Shows you nested for loops, shows you nested while loops, you know, and think about what you're doing, right? Don't just mindlessly memorize an example and go and try to make it work for every problem that you're trying to solve, right? You always want to look at examples in any video, any textbook or whatever as illustrations of the big idea being played out. The big idea is what's important, not any individual snippet of code. If you don't understand what the big idea is, no code in the world is ever going to help you. Don't memorize, understand, right? Memorization without understanding is completely and utterly pointless. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.